from the FAA on the US helicopter safety team and the recommendations.
Good afternoon. This presentation was actually developed by Scott Terrell from my office. Scott, I learned Friday afternoon late, was unable to come, so I consulted with someone else and thought I'd be able to give this presentation, so we had to leave on Saturday, but I did manage to spend some time on the presentation and believe we'll be able to complete on time and maybe help you understand what's going on with the United States Helicopter Safety Team. I'll warn you in advance, and I was actually reminded of the question we got on the second panel about is FAA and EASA going to harmonize on their acronyms. This particular presentation is loaded with acronyms. I'll tell you that in advance. I will do my best to use as few of them as possible. So I know when the teams are involved in their deliberations, these acronyms are extremely useful. They confuse some of the rest of us. So I will use as few acronyms as possible and still manage to hopefully do justice to the material. Okay, where do I aim? So the clicker is not working. Okay, so the U.S. Helicopter Safety Team took on a special objective. They are working off of the previous work done by the International Helicopter Safety Team, and as has been mentioned in some of the earlier presentations or comments, the fatal accident rate is really what we need to be all about. So that's what this team undertook. They looked at 104 accidents between 2009 and 2013, and they categorized each of those using common taxonomy. The taxonomy they used is not important for the purpose of this discussion, but they did two things. They categorized those accidents, and then also they looked at what industry sector did they occur in. So two things. This shows the various categories that they used according to the common taxonomy, the same type of process that was used by the commercial aviation safety team, as well as the general aviation joint study steering group, I think. Those two studies that were done for transport airplanes and small airplanes, they're using the same process, same categorization of the accidents. So as you can see from this, let me just pull up the next portion of this. Looking to the left side, you've got 50% of the 104 fatal accidents occur in only 3 of the categories, and I don't think for those of us that have followed accidents over 10 or 15 years, this is any surprise at all. You have loss of control, in-flight loss of control. You have unintended flight into IMC conditions, or IMC. And you have low-altitude operations. Low-altitude operations does not include takeoff and landing. It's other low-altitude operations. I can't give you an altitude, but it's low-altitude operations other than takeoff and landing. They then looked at the accidents by industry, what type of industry these were happening in. And again, the left side of the chart requires priority outreach. Those are actually 4 areas: personal, private, helicopter, air ambulance, commercial. Commercial includes operations other than air taxi and offshore, so other commercial operations, and aerial applications. And again, you've got 61 accidents in those 4 categories. And as you can also see, the green area in those 4 industries, as you can also see the green there, that refers to the categories we looked at previously. And if you can manage to positively affect that green area, that is, reduce the accidents in those categories, you can have a significant effect on fatal accidents. These are the industry members that helped analyze this data, and it is quite intensive, so a big thank you to all of these OEMs and operators. We also had some industry organizations, GAMM and HEI helped us too. Academia, we had Embry-Riddle helping out on this, and the government, we had the U.S. Fish and Wildlife Service, FAA, and several divisions within the FAA to help this. Okay, can get lost in the details in this particular slide and the acronyms. So they used a proven method that had been used by the CAST and by the GAJSC. The acronyms are there for you to look at. They looked at all the data. They developed standard problem statements, and then from those, there had 117 interventions defined from those problem statements. So that's almost twice the number. Well, it is twice the number of accidents, but they had 117 intervention strategies defined. And then they went through a mathematical formula, and I'm not going to cover that, but anyway, they ranked these by the overall effectiveness of the proposed intervention strategy, plus the feasibility of the proposed intervention strategy. I'll skip the math there, but basically just to show you that it was a very disciplined process in terms of the criteria they applied. These are the factors they considered when looking at feasibility, technical, financial, operational, and so forth. And then they again took a look at the 117 and looked at which ones fell above and below the Mendoza line. I don't know if everyone here is familiar with that term Mendoza line. I guess I've grown up with it, but I thought it was kind of like the line of demarcation or something. But it has its historical roots, of course, in baseball, U.S. baseball. There was a person, Mario Mendoza, back in the, I believe, 70s, who was an excellent fielder but a very mediocre batter. I think his batting average was around 200. That's not terrible, but every year the team had to decide, do we keep this person or do we not keep this person, because I said he was a very good fielder. So Mendoza line refers to what's above the Mendoza line, you keep. What's below the Mendoza line, you don't keep. So his name is probably mentioned much more than Babe Ruth or some of the other more famous baseball players, but his fame is tied to the Mendoza line. So those above the Mendoza line you keep for consideration. Those that are below the Mendoza line, you defer those for later or ignore them altogether. So there were individual our teams that volunteered to handle each of these HSEs, that just think intervention. Each of those interventions were people agreed to handle those. And they reduced this number from 117 down to 25. Then they did some more combining, and they came up with 22 proposed interventions to basically address these four top categories I mentioned a minute ago. The implementation plan was just basically who, what, and when, and how effective was it. Then they submitted these to the steering group, and they went through a series of committee meetings and so forth to decide which ones they were going to pursue and to gain approval of these implementation plans. The steering committee agreed with all but 4 of these, and they basically said, go back and do a little more work on these 4. So they have began to implement these interventions as of September 2013. They plan to finish those off by June of 2018. That is beginning to implement these. So they're rolling them out in stages, maybe 2 or 3 a month. They're saying, okay, let's tackle these, and attempting to do these interventions. So there are these next few charts are going to show you all of these 22 interventions. By no means am I going to propose to go through all of these. I'll have mercy on you for that. But I'll just say that these interventions can be categorized in about 4 different areas, which would be helpful on a slide like this. But they're basically their training, or their safety management systems, policy, or technology and equipment. Those 4 categories would cover all 20 some odd of these intervention strategies. For example, number 19A and 22A on this slide, they're really about safety management. Number 30 is about policy. This next slide, I'll pick one or two of these off. Number 37 is about training, basically revising the helicopter flying handbook to be more up-to-date and to address auto rotations. Number 70 is about technology and equipment. So those are just a few of the things that, of the 22, and they do fall into those very convenient 4 categories. These, by the way, I'm just going to flip through them. You can find them actually on the website. Let me see if I can find that website for you. Maybe I'll have that in a later slide. These are the ones that were deferred. I think the team actually meets fairly soon. They've done some rewrite on these, and these 4, they're expecting acceptance on these as well when they propose those to the steering group. I believe later this month they'll propose those to the steering group. So, closing thoughts. I would have thought this was the last slide, but it's not. So, there are a couple more to go. Closing thoughts. We do believe that successful implementation will result in fewer fatalities. Again, we're really, at this time, we're all about fatal accidents. I've got a slide I'll show you in a minute that basically confirms what's been said several times. We're not making the appropriate progress on preventing fatal accidents. Through the years, some of the presentations we've made here before, I think I made one year before last, that basically showed a curve of how helicopter accidents themselves are reducing. Fatal accidents at that time, if you look over a 30-year period, they're also reducing over a 30-year period. But of late, they've flattened out, and also the reduction in accidents is not proportional to the reduction in fatal accidents. You can have a pretty, which is an unexpected result, I guess, for us. The theory has always been reduce accidents, therefore you reduce fatal accidents. That's true, but it's not proportional. So the number of fatal accidents is actually flattened out. We continue to have some success in reducing the number of accidents, but the number of fatal accidents is really flat. You can go to this particular website. You'll be able to read much more. There's an entire report there, much more about these intervention strategies, exactly who's sponsoring them and so forth. So there's more information there. This is one slide I wanted to show you, and there's one more. This shows the goal that they have by the end of 2019 to have made a 20% reduction in the fatal accident rate from when they started back at the end of 2015. 2016 was a good year. As you can see, we were on target with 0.54. 2017 calendar year started out wonderful. We were doing quite well, but then we kind of had some problems. At the end of August, on a projected scale, we should have been down at 0.53 for the end of 17. But in fact, we had a very bad September. We had 3 fatal accidents in September. We had 4 in October. We had another 3 in November. So what really frustrates us about when we look at those kind of things is not just that it happened. There's a terrible loss of life, but why? And what's frustrating is that it was across the spectrum. We had HAA accidents, we had helicopter air ambulance accidents, we had aerial application accidents. We had just a number of different types of accidents, and we've had difficulty finding a common thread. Sometimes you can find a common thread and say, well, it's human, but in fact, in this case, we actually had some mechanical failures as well. So looking for the common thread, it just shows that this data is very sensitive. We thought about, well, is it harvest season, firefighting, whatever, and looked at all those parameters, and you don't find much. We've had some terrible hurricanes in the U.S., as you know, but you don't see that. We didn't see any accident increase at all during those times that those rescue operations and so forth were being done. So unexplained data is extremely frustrating to those who engage in this very good activity. So now, based on what's happened in those 3 months, we're back up to almost not making the goal this year. I'll also say that 2013 was our worst year ever for fatal accidents. 2017, if December is not a good month, we may also make a very bad precedent with 2017. So this is September, October, November. This would tie for number 3 out of 35 years for our worst 3-month period of those particular months. So we're not doing well. So we need to get back on track. put out a number of publications, continue to analyze the data. One of the things I would like to ask the team to do, and I haven't been close to this really, is I'd like for them to go back and look at the intervention strategies and say, okay, what if those intervention strategies had been in place for this 3-month period? Would we have helped? And so that's the real challenge, so we hope to get them to do that. And last slide I will show to you is just a shameless advertisement, I guess. We do hold our own International Safety Conference, a very different forum than this. In October of 2018, we plan on doing that. We've had 2 others. It's been, as I said, very different from this. We're trying to attract these personal private pilots and others who may not go to a large forum like AGI Heli Expo, which is excellent. But we're trying to attract the pilots that are actually out there having the fatal accidents, and we have them tell their personal stories. We also have a lot of help from the OEMs that are in the area, from other safety academy, for example, that are helping us out. We have students that attend. So it's a very different forum, but it's really, I really enjoyed it, I guess 2016. We skipped a year, but 2016 was very enjoyable. Have people get up and tell their personal experiences about how they got in trouble, how they thought they were in good shape to take that flight, but you know, they confused stadium lights with the full moon, the fog, how that got. So those personal stories related from operator to operator and pilot to pilot have really a good impact on our ability, I think, to improve the safety record. So that's all I've got to say. Thank you.
Thank you very much, Larry. More than interesting presentation. Now, I just, before introducing the next speaker, I just want to give to you some wording about why we propose to talk about the 9 vision operations, because a recent press article in a specialized magazine reported in Europe, the bulk of the experience of night vision operations is held by the operators rather than the regulators. Oh, of course, we have to react to this. You know, at EASA, most of our colleagues, experts, PCMs, etc., have a quite good experience on the aviation because in the previous life, they were already in a business. And at EASA, regarding the night flight and NVIS, we also have flight test engineer pilots having been this for years as a military people, for example. So we also have, I will say, the right to say we know what we are talking about because we have people knowing what they are talking about. So just to give you a view on our feelings is, I call Rafael DiCaprio just to go there and try to convince the audience. Thank you very much. Also?
I hope so. Thank you, Jean-Marc. It means to say that my objective today is to talk about night vision while the majority of you wants to fall asleep after lunch and the other part is already with his mind on this beautiful sofa at home. And of course, this is my objective today is to just to keep you awake and for the rest of the day. Yes, we found this press article on a specialized magazine. I'm not giving you any name, any reference, but it's easy to go there and look at it. Where the first sentence is already what is reported by Jean-Marc. The second one is also that the company that was speaking in this press article is aiming to increase the European Aviation Safety Administration confidence in the use of the technology so that MVIS can be more widely adopted to improve safety. Besides the fact that they misspelled our name, we are not an administration, we are an agency yet. But what puzzled us is that we have the message here that the majority of the people in Europe think that we are not confident with MVIS technology. and we are not putting enough effort on this aspect. And of course, we would like to let you know that we are doing something, and hopefully in the proper way. So my point today goes through, first of all, the difference between the operators and the EASA. We are different. We have different scope with one objective, which is safety. And next, let's try to answer the question, is EASA confident about MVIS? And next, in order to fulfill these two questions, what is EASA doing now? Let's speak about it. And then at the end, I will talk about the certification memo on MVIS issue 2, which I'm pleased to announce that last Monday was published on the website in the final issue. So, first of all, the difference between operators and the EASA. I ask you to think about a very simple comparison. Think about the violinist and the pianist. They both know how to read the music, they both know how to play, but they play different instruments. And they both have studied music, but they have gone through different experience and different training. If they know how to play, everybody can play on its own, but if they follow the same music sheet, well, you can imagine what beautiful music comes out. Okay, so we have operators. The operators, there's no doubt on that. They always have the core knowledge and accumulate always the most experience, the greatest experience of the system that they use. They use it every day, they use it in all conditions. Of course, MVIS is one of these. EASA, on the other hand, has another role, because we have to ensure that the operator have what they need. And we have to ensure it through the certification and proper regulations that you have what you need to do your mission effectively and also safely. So within this scope, we have to foster the implementation of new technology. And we have to identify any potential safety issue that this new technology can bring. In order to do this, we need to have experience and training, and we also need to have proper regulations. Please bear in mind these two red lines, because these are the things that we need, and we're going to see what EASA is doing in this respect. Talking about a little bit experience and training, as I said, I want to highlight our experience may start from the same, our training may start from the same as the operator, but we need to bring some more experience and some other training on other fields, like flight testing, like certification, in order to see what is the potential safety issue of any system. And that is what is differentiating EASA and the operators. Next, is EASA confident about MVIS? Well, there is a simple answer. Yes, we are. Yes, we are, because MVIS can bring safety benefits during any night operations. I think I have some people here in the room that attended a flight test that we were doing in a very dark night in the Alps about a couple of months ago. And I can assure you that with MVIS, I felt comfortable, we felt comfortable. Without MVIS, it was completely dark. So, yes, we are confident. However, though mature, MVIS is a complex technology. And as a complex technology, deserves some kind of certification, which is a complex process and, of course, is not an easy operation. And we need to tackle that in some way. On the other hand, we know that MVIS can bring safety benefits, but with some risk associated that needs to be mitigated somehow. And in order to do that, we need an appropriate involvement during the certification process. We don't want you to waste your time. We do want you to waste your money, but we want you to have the safest system in the world. We need standardization, because we have to fulfill our main objective to bring everybody to the same highest possible safety level. And then proper regulation again. We need to give you the proper guidance in order for certification for DOAs, for APDOAs, and for any other in the operation of ENVIS to fulfill their mission in a safer way. So, what is EASA doing now? First of all, let's talk about experience and training. You may understand that the majority of the ENVIS projects involve mainly flight test personnel. All our flight test personnel have a solid background acquired both in military and civil certifications and operations. We also tackle to maintain currency of these people with involvement in ENVIS certification projects every year, or if we don't have any certification project, we seek for operational training in order to be exposed as much as we can to the operational needs, to the operational world. We need appropriate involvement during certification. And of course, this should trigger in your mind the recollection of the level of involvement. We said it's a complex technology. It's not easy to bring an aircraft from a non-ENVIS helicopters to an ENVIS approved helicopters. So we actually participate in grounded flight tests for any full ENVIS project. That is not only for the sake of it, not only for the sake of the certification. Bear in mind that this brings us exposure to operations, and therefore we also better understand what is the ENVIS usage. Also, this exposes us to change in designs, to new technologies, and certification approaches. We will see that since some years, in EASA, we have established for the DOAs and the PDOAs the ENVIS capability, looking at ENVIS as one discipline on its own, because it's a complex discipline. So we have a close cooperation in the certification directorate between ourselves and the DOA department for approval of ENVIS capabilities of any DOA and APDOA. And this is ended usually with at least one project run with high involvement from the agency. This will allow us to be confident of the capability of the company, and therefore we, in the future, to let them work on their own more and more. For standardization, you may already know that recently EASA established an ENVIS focal point within the Rotorcraft department. If you want to know the name, here I am. Nowadays, I inherited actually this role from Riccardo Frollo, which I thank for the outstanding and excellent work that he has done so far within the department. I'm trying to give myself some objectives and to fulfill them as much as I can. First of all, PCM and all certification teams coordination. We have understood quite some time ago that the certification of ENVIS projects cannot be led by one person. One-man band doesn't work because there are too many now. The number of certification projects on ENVIS is increasing more and more. So I'm trying to coordinate and to make sure that every PCM and every single expert is treating the project on ENVIS in the same way. Policy definition. I'm talking to anybody and as a stakeholder to understand what is the lack in our regulations, what is the lack in our policy, and to better define it. And you will see the CERT memo goes in this direction. Today we have, and you have, a unique entry point for external queries. You just ask the question either to the Rotorcraft mailbox or to myself. You will get an answer which is coordinated within the department from one person. And of course, we also try to share experience and lesson learned with all the stakeholders, even with the FAA, TCCA, and ANAC. Regulation and guidance material. I think nowadays we have a bunch of regulation that is addressing operations and certifications, And we are trying to, of course, to optimize this as time goes along. Parts by MVs, I find it, of course, everything can be done better, or ways can be improved, but so far, I think SPI MVs is one of the best regulations that we could have in the operational world and for training. If you want to know what is MVs about, you just go there, have a look at this regulation, the guidance material in there. I think it's a very comprehensive document. Recently, the FAA has progressed after a certain numbers of talking with the EASA experts. They have published this change 7 of the AC 27 and 29, in which you can find the new MG16. And I will talk to you about that later, because that's the newest guidance material that you can have from the FAA. And finally, as I said, the certification memorandum on NVIS issue 2. It's been published in final after consultation. Please go and read it. I would like to highlight some reason that brought us to the issue 2 of the CERT memo, and some points that are important to understand. First of all, since the first issue of the CERT memo, we have issued a number of regulations that, of course, we need to address in the CERT memo itself. Part FCL, part SPI MVs, the new part 21 dealing with the flight test and OSD. So we can't have a guidance material from EASA that does not address these new regulations in place. And of course, we wanted to give you guidance to follow whenever you want, whenever it's possible, the change 7 of the AC material. I will tell you in a minute why I said whenever you want, whenever it's possible. We tried to address some lessons learned and experiences that we gathered during the issue, since the issue 1, in all our certification projects. And of course, we had the need to clarify certain policies on NVIS certification. I don't want to read the entire list here of what is new in the CERT memo. I think it's worth to highlight mainly 3 points. One of these is the eligibility for NVIS design changes. The other one is the clarification on the MG16. And last but not least, the white phosphor MVG. You will see this is one of the examples of how EASA is addressing new technologies coming up. Eligibility of NVIS projects. We have tried to address the proportionality concept among DOAs, APDOAs, any other legal person, and to introduce once for all the NVIS capability concept. You may argue that there may be some check marks and crosses that can be changed. For the time being, this is what we are trying to do, what we think it's appropriate at this stage. The most controversial point that you can see is this one. We already have some APDOAs that are SDC holder. We recognize that. However, the SDC itself, of course, cannot be withdrawn because, of course, when we granted the SDC, this was granted also thanks to a full involvement of the agency. So we cannot say that the SDC is unsafe. However, we have to recognize that given the complexity of the NVIS design, given the complexity of the full NVIS certification, we are not sure, we cannot be sure that an APDOA that we can not oversight in the same way we oversight a DOA is capable to do NVIS design and certification. Therefore, from now on, while we will require that the GM 112 to GM 21 112 is going to change in order to address this point. Any APDOA that is looking for a new STC has to apply for a DOA. Next point is clarification on the MG16. Nowadays, Amendment 4 of CS29 has in its book 2 reference to the AC29 change 4. So the FAA has recently, last year actually, published the change 7, and of course does not go into our book 2 yet. We are going to, working on it, and we are going to endorse the change 7 by mid of next year. However, we think that the change 7 and therefore the new MG16 represents the most advanced guidance material that you can have on NVIS. Therefore, all applicants are encouraged to use the MG16 change 7 and as an alternative means of compliance. Our CM also clarifies some differences between the MG16 and our policy that is only explicitly addressing EASA certification points. White phosphor NVGs. We thought that this new technology deserved at least a paragraph in our cert memo. They have been on the market and in the operational world since 3 years, maybe. We recognize that they are much better than the green phosphor NVGs. As you can see here, the green over black image is not looking like the black over black image. It is much more defined, and also what you can see is that one of the defects of the NVIS, which is the 2D image in front of you, while with respect to the 3D world, is a little bit reduced. However, there are some other points that need to be addressed. One of those is, for example, you see here, as you can see, the halon of any cultural light is reduced. However, if you try to move your head a little bit, this white spot here creates a little shape, black shape, that is following the white spot. And we need to see what is the effect on this, on the pilot fatigue, pilot workload, and the image. We have received also questions, can we use white phosphor MVGs and green phosphor MVGs on the same copy together? We have to address that. We need to get some experience in the next upcoming certification projects and operational training in order to see if this can be allowed. For sure, today you have some NVG models that have both green and white phosphor tube with no difference in name and part number. So you get the goggles and you can have it white or green, but your part number is not reflecting that. So we asked to have the first introduction of the white phosphor NVG as a major change for your NVC certification for the time being. We can relax this in the future. And we asked to have a reference in the RFM whether any NVG that you are approving with your certification is either white phosphor or green phosphor or both. And of course, as the operational rule says so far, we asked to have for all crew the same kind of tube as it was for the same kind of NVG model. Conclusion. EASA is confident about NVIS, and we think that it can bring a lot of safety benefits in the night VFR operations. EASA and the operators have a different role, for sure, and therefore they should have different training and experience. EASA, we can assure you, is putting a great effort on NVIS certification and rulemaking activities. And please, go and read the issue 2 of the certification memo. That's all from mine.
Thank you, Raffaele. We are now welcoming on stage Dmitry Praslov and Alexander Tarasov from MIL Moscow Helicopter Plant.
So hello to everybody. First of all, I want to thank you, EASA and the chairman, for the opportunity to be here today. And let me introduce to you a small report about the Me-171A2 helicopter, the new model of famous Me-8, Me-70 family. Just a couple of words about the history. The first prototype of Me-8 helicopter, the Me-8A, took his first flight during June of 1961. It was equipped with a single turbine engine with an electric start. The first helicopter in bench production was established in 1964. It was the Me-8T, means transport. And the next year, 1965, the passenger model with the same twin turboshaft engine with electric start was put into production. In 1975, the new model Me-8MT, modernized, also known as Me-17, was put into production with the twin turboshaft engines TV3-117 with air start and auxiliary power unit IE9. And after that, in 1991, the first model for the one of the aviation plant was established, a modified Me-8MT, the Me-8AMT. It was equipped with a twin altitude engine TV3-117VM and the same APU. And after that, the times there are changes. We came into the new era, and since that moment, we made our civil helicopters certified. And in 1998, the Me-171, the certified version of Me-8AMT, the new certificate number 99171 was issued. After that, we made a couple of modifications, and the main of them is a model of Me-171A, the cargo and passenger at the same time version of the helicopter Me-171, and next the model of Me-171A1 for Brazilian operator according to the Brazilian aviation requirements. So nowadays, the helicopters of Me-8 and 17 family you could find everywhere from the north to south, over the water and over the fire. And now the new model Me-171A2 is the top of the family. The general dimensions could be found on this slide. They're the same as for all the other family guys. And the flight performance characteristic you could find in this table. The helicopter payload to payload to range diagram here with the maximum takeoff weight of 13 tons and the main fuel tanks fueled for over 2 tons of kerosene. So, what else to the higher level of safety could provide the new helicopters? What advantages do we have? First of all, is the high volume cargo cabin. Its volume is more than 20 cubic meters. And we got a large, wide door on the starboard, and a white cargo door apparel at the back of the cabin. As you could see, the same helicopter could be cargo version and the passengers version, and the operator could change it one to another by itself. As nowadays is absolutely normal for everybody, no one could make something new in some new aircraft without the international cooperation. So in this project, there was Velka British that provided us with the auxiliary power unit, the Fisher seats equipped for both for passengers and for crew. The PAL Corporation provided us with dust protection devices, and the Aviatest from Latvia made a lot of stress and fatigue tests for us. Surely we use the PLM software, we use the Siemens PLM software, Team Center and the X10 version. A couple of words about the technical features. The power unit, we use, as I've said previously, the Saphir high power APU by Velka British, a new engine with FADEC by Klimov with a high power, and dust protection device by PAL Corporation. Transmission and tail rotors. We use a modified transmission with less slew points and longer flying life. The new X-shaped 4-blade high-performance tail rotor, and the main gearbox with twin circles loop system. In the main rotor, we use the new made of composite materials main rotor blade. They're the same rotor blades as we used on Mi-38, but Mi-38 got 6-blade main rotor, and Mi-171 has 5-blade rotor. And we got a modified swash blade with less loop points and longer flying life. One feature is avionics. The new KBO-17 complex includes the piloting and navigation equipment suite, sure it's the glass cockpit, information control suite, radio communication equipment, and for the first time for Mil Moscow helicopter plant, the general helicopter equipment control. Because of this system, we could provide only 2 members crew with no flying engineer. So the new certificate was issued for for all the models of Mi-171 according to this model. Unfortunately, I made a presentation for the Windows operation system, and I just don't want to play all of my videos. So imagine this on this black square, the lightning strikes right into the rotor blades. And here's the Iron Bird test rig, more than 300 of hours. Took the tests. Here we can find the HIRF test. Now 2 nice videos, the DPD bird strike from outside and from inside. Now here we got the AUTOROTATION landing flight tests with all engines switched off. And nowadays we are working on the icing condition testing. We finished the first stage, the rotor blade icing states analysis. Now we're currently finishing the rotor blade element tests in a controlled environment test chamber, and we're now starting, as we planned, the 3rd stage, the helicopter flight test in natural icing conditions. So we equipped the helicopter with a full icing protection system, including icing detector, automatic activation system with manual backup, engine intake protection, heated windshields and pitot tubes. And surely the main and tail rotor protection. So we got the first operators. It's usually our usual markets from Russia, from Kazakhstan, from India, and from China. That's all. I hope I was short enough. If someone is interested in, please don't hesitate to contact me. I will send you the full late presentation with the walking videos. Thank you very much.
Thank you very much, Dimitri. And now we are calling the last speaker, Mr. Enrico Ragoni. Please. Drop test, simple and complex PCDS in case of a gap after primary cargo hook opening.
Hello. We tested last year some kinds of ropes with a drop test. After a long time with flight testing with different kind of ropes, also for human external cargo, we want to know what is the impact after a drop. The basic for this test was the EASA certification memorandum for simple PCDS for design and calculation of these ropes. And the product was different textile fixed ropes for human external cargo and also steel cables or steel cable for a rescue hoist. We test this in a location nearly Düsseldorf. This organization, BG Bau Arbeitsschutzzentrum, is a test facility and notified body for type examination certifications of personal protective equipment against falls from a high. And we call it in the aviation, in the EASA world, personal protective equipment against falls from a high as simple PCDS, like carabiners, lanyards, ropes. The lead in this test certainly has the organization BG Verkehr, BG Transport in Berlin. They are responsible for all helicopter operators in Germany, for safety in work and with techniques. He was a participant with different ropes from different manufacturers, also from myself, and with the Bern University of Applied Sciences, they have all measurements documented. Different guests was the EASA and from Airbus and from the German Border Police. This was our testing facility. 9-meter high tower with any kind of measurements. It was a paradise for testing. And on the right side, our testing mass, 252 kilograms, a steel body. Two examples for the operation. The first is the double cargo hook, in this picture from the H135. And the gap between the both hooks is 30 centimeters in horizontal, and the gap between the lengths from these both ropes is 170 millimeters. And the free fall in this free line from this gap from 170 millimeters was our interest, point of interest. Similar is the operation with a hoist. Also in this operation we could have slack ropes, a gap. We need the same gap, 170 millimeters. And these booth gaps are very similar to a situation on a spider park with via ferrata equipment. A free fall in a slack rope is a very, very hard shock load. It's very painful for the pupils. The rope we tested, the first one was a rescue hoist steel cable. This mill standard number on the end is not 8, it's on a B. You can see the technical data from this rope. And we test with 252 kilograms. The safety factor is 6.2 in this rope. The second rope is a textile rope for hoist. It's a new design. There's no standard required at the moment. We test with the same mass. The factor is 10.9. What is this? The textile rope for fixed rope for human external cargo. We have two different. The first one is a can mantle rope by a European harmonized standard EN 8091. Can mantle rope means can mantle rope with low elongation. The standard that by 100 kilogram is accepted 5% elongation. We test also with the same mass. The factor is 14.9. The workload is a little bit different, is 270 kilograms. This rope is made by polyamide. The next rope is a rope made by high modular polyethylene, called as trade name Dyneema, for example. It's very stiff. We have under workload less than 0.5% elongation. And in accordance with the test sample mass was the factor 21 and higher. Our test requirement was we have a fixed rope with double cargo hook, Yankee rope, attached on a helicopter. The case is the main rope is in the primary cargo hook. The secondary rope, the backup rope, is in the backup cargo hook. When release the primary cargo hook, the load falls in the backup rope. This is the gap 170 millimeters. And the picture in the middle is was the testing from a 600 kilogram rope. We tested also with 600 kilogram test mass, for example. The other case, the steel rope. We say we have a slack rope, the same gap, 170 millimeters, the same load, 252 kilograms. The workload in the praxis is 272 kilograms for this kind of rope. The results. We test a lot of different ropes. Here you have only 4 examples. Every time the same drop height, 170 millimeters, every time the same mass for testing. The G-load, the shock load, in this case with the rescue steel cable, was 12.68 kilonewtons. The G-load was 5.30 G. And for comparison, for occupational safety and health, with personal protective equipment, the accepted shock load is 4 G after a shock load damper. The gap, the shock load to the design from the rope was very close to ultimate load, short before breaking. In comparison with the design loads, in accordance with the EASA rules, is 3.5 accepted for design load, and the gap was more than higher. The new textile rope, all ropes was between 5.5 and 6 meters long by this test, all ropes. The shock load was 8.54 kilonewtons. You could remember before we had with the steel rope 12 point, now we have 8 point. The G load was 3.45. Is for both requirements accepted, is less than 4, less than 3.5. A fixed rope with this standardized can mantle rope with long elongation. It's limited to 2-person transport by the EASA rules for simple PCDS. Was the shock load 2.38, very good. And the G load, and the shock load 5.87, also very good. We have enough reserve between the requirements. This is not right here. Here must be written 365 kilograms. We test also with the same mass and the same height. The shock load was 15.68 kilonewtons. You could remember Dynamo with low elongation. The G load was very high, 6.34. We have a big gap here in the G load to the accepted G load, and a big gap to the accepted G load here by the EASA rules. We test also, in this case, without the damper, and the result with a damper. Oh, sorry. Restart. Sorry. With the damper, we means a shock absorber made by a polyamide rope with 10 or between 10 and 15% elongation, a short rope between 1.5 meters. With a shock absorber, we have absolute positive results. During the EASA certification from a 600 kilogram fixed rope system for H135, we tested also with 600 kilograms, and we have a G-load with damper from 3G. Okay, this was one example for our testing series. This is the starting point for more testing series with other conditions. Maybe next year on the same place. Thank you.
Thank you very much. Interesting. Now you know better how to go to undersling. It is a very critical situation time to time, but we have seen not easy to understand what will be the good ratio there. Just before starting the question and answer, I just want to remember you have now on the website published a questionnaire regarding the Rotorcraft Symposium. Just please, if you have a few minutes, just to fill in. We appreciate to better understand what you feel about this event, and also to try to have, for the next one, some improvement and to propose you some other solutions. So please, take you a few times from you, and thank you very much. So now, for the questions. First question, please.
Hello, I'm Patrick Lantery. Yes, a flight test pilot. I have a question on the MI-171. On some slides, the tail rotor is located on the right-hand side, and the other slides, the tail rotor is located on the left-hand side. If it's confirmed that the tail rotor is located on the left-hand side, meaning you change the design from the previous version, and meaning that you will have interaction of the airflow with the tail. And so in this case, what is the reason you change and you have the left-hand side location for the tail rotor?
Thank you. No, it's just made by Photoshop. Just return the face.
So it's right-hand side.
Oh. Does anybody remember? Unfortunately, not.
Thank you. Next, please. Yes.
I have a question on the last presentation on the ropes. The drop test, did you include or consider the fact that the helicopter is not a perfectly stiff system, but will dynamically also give way when there's a drop, something dropped a weight dropped onto the helicopter?
Sorry, I don't understood.
Yeah, my question is, did you consider the fact that the helicopter itself is not infinitely stiff? So if you drop something that add a load to the helicopter will also dynamically give way to the load. In other words, the loads may be a lot less than what you measured.
After the shock load, when the cargo hook goes open, the helicopter will have 1 or 2 seconds later to a reaction in this way.
Have you compared measurements on helicopter and on the test rig?
No.
Tend to do that?
Maybe.
Another one?
Hello, question to the FAA that may be extended to EASA. When doing your safety analysis, are you also comparing or including military rotors and state aircraft? Thank you.
Our study was just for civil aircraft. So we took like a 4 or 5 year database of fatal accidents, and that's where we worked for looking at the interventions that were needed.
That's okay. Next, please. So, no more question in the room? So we can go to the Slido. Question number 1. And this? Raphael?
Yeah, the question is why all crew should use the same type of phosphorus? Is this based on any study? Thank Louis David. Really appreciate this question. No, it's not based on any study. And this goes in the direction that I was saying. We need to gather some experience on the model, on this new technology first, and then we can see what we can do on this respect. For the time being, we have only the operational rule that requires to use the same type of NVG for all the crew. That's it.
Okay, next for the ME 171 Alpha. Mitri?
Which one is next right now? At 23 passengers, yes, we need an air steward. And now it's situated on the same seat as the passengers. And about the tail rotor on the left side.
Next one. David, you want to take it?
Next one is once again for me. Yeah? Surely we
EASA.
prepare an application for EASA, but nowadays we are at the finishing of preparing the necessary documents, but we're still waiting for your interest. We still want you to contact with us and say that you're interested in it, that we really should do it. And about the car 32, I think if you help us, you should. I will address this question to Mr. Shamil Abdulbarovich, the general designer of the car 32. He's present here.
Okay. Next, certification in Canada.
Nowadays we have no such a plan, but if we find that in Canada the operators are interested in it, surely we will start the process.
Okay, next one to Raphael. What is a Navy's friendly modified?
Yes, thanks, Manfred. I think you have the answer more than me. For the sake of the all of us, we found that the MBIS, some helicopters have already cockpit lighting, which is MBIS friendly, so-called, meaning that all the equipment are MBIS compatible, but they have not, the helicopter has not undergo any certification on MBIS. And is most of the time sold by the manufacturer as it is, with no difference in part numbers with the others MBIS certified helicopters, other than not giving the flight manual supplement associated, and of course the certification associated. So that's what we mean MBIS friendly helicopters. There are a number of cases in this respect. One thing that we have tried to do with this within the CERT memo is to have a unique wording for identifying MBIS friendly cockpit so-called, and also NVIS compatible lighting, mostly referred in other domains, in other papers, as the with respect to the external lighting of the helicopter. So we try to include both in one unique wording. I think I have another question on NVIS. Was the industry involved in the preparation of the new CM requirements for NVIS, not only in the comments phase? No, we did not think to involve the industry so far, because most of the changes were only to clarify what EASA was already having in place so far since the issue 1. You will find the complete rewording of the cert memo, but the matter is already there. There's no main difference with what we have been doing so far. So there was no working group involving industries for the new cert memo, and also for all the other parts that are related to the new regulations in place. We haven't seen any need for involving the industry for that. Of course, next issues may be different. I think I have another one. Considering the effort for a DOA to gain NVIS capability, the APDOA acceptance to perform major changes seems not proportional. Means APDOA get it too easy. Thanks for the comment. It's Franz. It's a comment that you raised also during the CRD, the comment phase. We have been talking a lot within EASA about this. Actually, we have to say that APDOA is a reality, and we can't deny that there is some sort of design capabilities within these small companies that have also demonstrated how they can work on NVIS. On the other hand, we have tried to limit the eligibility of the APDOAs, because at a certain point we have recognized that the NVIS design for a complete full helicopter to be modified from non-NVIS to full NVIS requires an effort, capabilities, and competencies that need to be also oversighted as for a DOA. So that's why we limit to those major changes. But yes, of course, we can always review this policy in the future. Is it possible to certify an NVIS-friendly cockpit with an NVG that EASA does not know? The cockpit will be certified, not the NVG goggle. This is a very recurrent question that we have on the NVIS. The goggle, how is the goggle certified? How is the requirement that the MT16 has to have an NVG which is ATSO compliant in the certification? So far, we have, as for any other equipment that we have in the aircraft, in the helicopters, we don't ask specifically for an ETSO. You can demonstrate the fulfillment of the compliance to the certification requirements by your own. And by that meaning that if you read carefully the MG16, it doesn't say that you have to be ETSO approved, but that you have to be ETSO compliant. That meaning that you can demonstrate by yourself compliance to the DO275 requirements, which is the minimum operating performance specification of the TSO C164. I think that's the correct number. I think that's a general question for you, Jean-Marc.
Yes. So regarding the question about the Slido, the response is no, we cannot provide you all the question and the answer behind. So what it is possible to do, you will have all the presentation, all the speakers, etc., with email address, and you can ask again the question to every speakers depending on the question you ask them. So we cannot provide you a summarizing of all the questions.
Do we have time for other questions, Mark? Okay, let me answer this other one. What is the FAA involvement compared to the EASA approach? Okay, before handing over to Larry for answering this question, what I've seen so far in all the MVIS projects that we have run is that if you read the MG16, they state that any MVIS modification, including the full modification and any modification to an MVIS certified rotorcraft, is a major change. Actually, in practice, that is not that does not reflect reality, because the FAA used to have plan for safety partnership, something. Partnership for safety plan, which is agreed between the FAA and the applicant, in which they can agree on certain classification of changes. And depending on the classification of changes, they have a certain level of involvement. I don't think at the end we have a different approach. At the end of the day, you will find a very similar approach. Full MVIS means full involvement by the authority, then major changes depending on the kind of changes, there's a less level of involvement of the authority.
Well, I don't have a lot to add to that unless one of our specialists on the other side does. Andy, got any more to add to that? I think we've got our MG16, that's what we rely on. We do have concerns with standardization among the different ACOs. Some view it differently, but even with our MG16 out there, we do have some standardization issues, so it does involve some time by the standards branch.
Just to add what is Larry saying, the CERT memo is complementary to the MG16. Having said that, it does not mean that we require, if you see the CERT memo addresses things like configuration control and OSD and so on, but those things that are required by the CERT memo it is not meant that those things are not followed by the FAA at all. Configuration control is part of the certification process followed by the FAA anyway. As a matter of fact, any company that seeks for MVIS validation in Europe has the answer to the CERT memo very ready. As information, is EASA willing to share how many DOA in Europe have an MVIS capability, 5, 10 or more? I don't have an exact number in my mind. I can tell you that we have an increasing numbers of applications for significant changes by DOAs that seek for MVIS capabilities recognition. So I can tell you the exact numbers afterwards, but so far I have not an exact number from this. Still on MVIS, wow, you put me under pressure. Could tech crew members in the cabin, rear crew, potentially use different NVGs to flight crew? That's a good question. What we have seen so far is that the operational rules requires for one single NVG model for all the flight crew. Sometimes for certain operational maneuvers, there is a limitation with which the crew member, the additional crew member is required, but it is not required to stay up front in the cockpit, but he can stay in the cabin. And with this respect, in that particular flight condition, I would not consider it as a technical crew member, but as flight crew member. So the answer is yes, they have to use the same. So that, but of course we can debate on that.
Question number one, Enrico.
Yeah. Okay. Roy asked me, why did you choose a 170 millimeter gap and did not reduce to the no gap? It's a hard fact. I can't change the design from Eurocopter or Airbus. We have in line 2 hooks with a gap from 30 centimeters. In flight direction is the backup hook, and backward is the primary cargo hook. And there's another hard fact: this primary cargo hook rope must have, in any directions, 30 degrees free moving. And in case of backward, the backup rope must have length enough for free 30 degrees, and this is the gap 170 millimeters. Thank you.
Do I have time?
Yes, it's for you again.
Okay, no problem. I was expecting a lot of questions, so it's fine. So what's next? Is EASA aware that the new technology LED obstacle lights, red, are not visible in NVG latest generation anymore? Do obstacle lights also go into the guidance material? Thanks for the information. we will address this, and yes, of course, there is room for anything that needs to be clarified in the guidance material, as usual. We don't want to have a certification memo that becomes a melting pot, and therefore, at the end of the day, would be useless. Of course, there are some operational risks that are addressed at the operational level. So we have to see if these can be properly mitigated at the operational level. So we will leave it to the operational domain. If not, we can address it in the certification domain. Next, still on ENVIS. Wow, I got my objective today. I really kept you awake. Okay, so you recommend using AC change 7, but state that is not yet EASA endorsed. Could you clarify? Yes. Change 7 is not EASA endorsed. The latest revision of the AC material endorsed by EASA is change 4. Nevertheless, the change 7 is considered, from our side, the latest and most advanced, the best available guidance material, so we can advise you to use that. Of course, whenever the change 7 will be endorsed in the book 2 of EASA airworthiness requirements, we will amend the CERT memo in this respect. Yes, please.
Hi. The point of endorsing is to basically say we can use it. So to say on the one hand we can use something, but you don't endorse it yet, is a contradiction.
In the book 2, but we encourage you to use it. If you explicitly state in the certification plan that you want to use the CERT memo change 7, we don't even require a CRI for that. It's period. We agree among us that you are using the change 7. The spirit of the guidance material does not change. It's just better rewarding and organization of the guidance material, and also explanation of some additional things that we, EASA and FAA, have learned along the years. So there's nothing that is requiring more or less than what was done in the past.
Thanks.
Next question is CM2 eligibility restricting even minor changes not related to MVIS itself? The slide is not clear. Yes, no, not at all. We are not restricting any minor change which is not addressing MVIS, which is not impacting on the MVIS capability, and in particular, any minor change which is not impacting on the lighting, it is not included in this eligibility criteria, of course.
Thank you very much. We have to close the session because now we're on time, and I will give the floor to Trevor Woods just to finalize and to have a wrap-up and feedback. Thank you, Trevor.
The slides, or are you? Just amuse yourselves for a few minutes. I have a very technical slideshow for you, fireworks, sound effects, everything, so it's complicated. Come on. This is really important and worth waiting for, so I'm sure you'll appreciate it when you see it. Okay, thank you for bearing with me just for a few minutes. Good afternoon. What did you think? Was it a success? Okay. David is glad to hear that because, you know, performance appraisals coming up and things like that. Okay, good. I tuned in and out of the YouTube. I came in and out of sessions. It seemed like a really good discussion to me. The questions seemed very good, very helpful, and adding a lot of value. So to me, it seemed like a success, and I think we're building on each year to what we learned last year. This year we had the Slido. We've been trying it on a few conferences, and I think we can only get used to using it and improve the way we use it, but it really gives people the chance to ask questions, vote for questions. I think this is a great tool. And we had live streaming. If you're joining us on YouTube, welcome again. And this is another way of opening up the discussion more widely. So next year we'll be building on this. We've got some different ideas. We'll have a discussion between now and then, especially with the EHA, to see what's the best format for next year. Of course, we're here to share our experiences, share what we're doing with you and your priorities and issues and the work you're doing with each other. And that's really the main reason why we come together for this. We've learnt, well, I think we know, but we've really emphasized that new technology is coming. And I think when new technology comes, you see it coming at a distance. It's a bit like a parachute jump. You see the ground coming, then suddenly it hits you. And we've heard about fast helicopters, tilt rotor, electric VTOL, UAV. Patrick Keyes said he doesn't know the difference between a drone and a helicopter. Where do we draw the line? And I think that there'll be a lot of areas like that where there are grey areas in between things. Is it a helicopter? Is it a VTOL? Is it an electric autonomous vehicle? What is it? So our rules may not exactly fit traditionally the way we expected before. Other technology is going to come. Artificial intelligence. We really work hard to agree how to qualify software. And now we're going to have to face artificial intelligence in the future. And we already see it in some areas. It's being used in the aviation industry in some areas, but we'll have to enable it to be certificated and used on certificated machines. These will be challenges for all of us. I think that we heard about how much progress we're making on safety, and there's no doubt that over the past years we've made a lot of progress, and a lot of progress to develop new rules, new equipment, new technology, new operating techniques, training, and so on, towards improving safety. But I really feel that we've got an opportunity to pull all that together and really implement it in a way that we can make a step change in safety. One accident a week, one fatal accident a month is too many. And I think we need to really harvest what we've done so far to really improve safety. And we see how the design of the aircraft and the operation of the aircraft, the training of personnel, the production, the maintenance, the air traffic, everything, if I forgot one of your domains, everything comes together, and we need to join everything up to make that step change in safety. We heard about regulations, some discussion about CS and FAR 27, 29. How objective should we be in the regulations? How performance-based? And I am sure that we're going to move towards objective and performance-based regulations. It gives more flexibility. It enables new technology to be introduced to improve safety. And it can give us performance targets we can really work on. So this is an area we're going to need to work with you to make good progress. You heard Patrick, during the opening speech, talk about the basic regulation. And these will bring changes to us, which will imply changes to you. We will have new remits. The states and industry will have be able to opt into the system in areas where they couldn't before. And that means we can have a better joined up system in those areas. Elisabetta made a suggestion that we should give visibility to the opt-ins so that everyone knows who is complying with which requirement. I think that's a good idea, so we'll discuss how we can do that. So there's a lot coming and a lot for us to do. And I'd like to thank some people for organising and working on this symposium. Paula, Anna, that's two Annas, not one twice. Agatha, Joanna, Yannick, Oceana, Arnie, thank you very much. Let's give them a round of applause. They've done it. It's a lot of hard work for our staff to organise these. I'd also like to thank the rest of my team. David has come to Rotorcraft with a lot of enthusiasm, and I'd like to thank him, and also Clément and all of the other EASA staff that took part to make presentations and pull work together for that. So perhaps a round of applause for them. The Marriott technicians have done a good job keeping all the equipment running, keeping us working smoothly. So thanks to them. And the team from IFBBW for the live streaming. It's been working very well from my sampling from my desk. Thank you. And I'd like to thank the FAA and Transport Canada for supporting this event, and not only supporting the event, but working through the year on our partnership with them, because we have limited resources. Not only that, but if we have different rules, regulations, procedures, and so on, it makes your life a misery. So thanks for FAA and Transport Canada. Jamie, where are you? He's gone. Okay, but I thank Jamie for his opening speech, all of his contributions to these symposiums, and I wish him a very good retirement. I think he said April next year. So anyway, it will be broadcast on YouTube, so Jamie, thank you very much, and good luck. Is there anyone in the room that likes oil painting or does it in their spare time? No? Oh. Jean-Marc. You may or may not know Jean-Marc is going to retire very soon. I believe your last day next week, 15th. Jean-Marc joined us in March 2019, and he's made a huge contribution to EASA. 2009. He's made a huge contribution to EASA since then, and more widely, helicopter safety community. And you can see from a boy through his career there, he's contributed a lot even before he came to EASA. And I just wanted to thank him for that, especially as this will be, well, maybe perhaps you'll come back next year from the dark side. But who knows, but thank you very much. If you've been in our building in the last week or so, you'll see that we had a hidden artists exhibition where people displayed their art, and there were some very nice art pieces from Jean-Marc. So this is an advert for his next career. If you'd like to bid for some of his work, see him afterwards. But Jean-Marc, thank you very much, and very best wishes for your retirement. Thank you. Okay, we can. Normally, in a conference, symposium, something like this, I would say at least find one thing that you heard, take it back to your organisation and do something with it. And if you all do that, then together we will have made progress. I feel we need a bigger challenge than that now. What I would like to see is this graph of safety. I would like to see a kink in the graph now. Moving forwards, I'd like to see us implement all these things we've been doing and more. And everything we do, think, what can I do? What can my organisation do to improve the safety levels of rotorcraft beyond what we've achieved now? Let's work together to make a step change in safety for rotorcraft. I think that this is something we would all want to see, and I think it's an achievable. I'm not going to say we will achieve 0 accidents by the end of next year, but let's make an order of magnitude change for rotorcraft safety. So I'd like to leave you with that challenge. And then all that's left for me to do is to say thank you very much for your contribution. Let's look forward to next year and build on what we've done this year. And please enjoy Cologne and have a great Christmas. Thank you.
I will keep it.